Hello, I am Professor Bodziak, and I will be your science teacher today. And our topic today will concern electricity, and it's basically electrical safety. At the end of the lecture, I will ask you to answer a question. Please put the answer in your chat section, include it as part of your chat. If you watch this lecture on YouTube, put it into the comment section. So I will be talking more about the topics contained within this book called About Electrical Safety, made by First Energy Company. Electricity is our number one energy servant in our home. And I had come up with the thought that, an oil company might think that electricity is not their number one servant, but we use gasoline to power our cars and our gas-powered lawnmowers and so forth. However, no doubt, very, very important. We're using electricity for cooking, our electric stoves, microwave ovens. We're using our electricity to clean, our vacuum cleaners. Some electrical dusters exist that have electrical motors in them. Cooling is powered by electricity. So especially in these hot summers in this part of the country, we have air conditioning that we rely upon that need electrical cooling. Freezing needs electricity. Our refrigerators keep our food so that we don't need to go to the store every day, the grocery store, and buy new food, and we can keep our ice cream cold and icy, so it makes our food taste better when it's hot, or cold. It's cold when it's cold. Some of our food tastes better, as opposed to heating it on a stove where some food tastes better hot. All right, so an electrical heater will serve as something important to us to keep us warm in the wintertime, powered by electricity. All the lighting that we have in our homes, our electric light bulbs, are going to be relying on electricity so that we can stay awake at night instead of going to bed when it's dark. And our entertainment relies on electricity. Our TV sets, our computer screens, our radios and stereos and so forth, powered by electricity, are so important. So when we're dealing with electricity, electricity is basically electrons moving through conductors, and these electrons can have great energy associated with them, depending upon what voltage source they are coming from. And the voltage source coming out of our homes is 120 volts, which is reduced from about 4,000 volts that our electric power companies transmit through telephone poles, and devices on the poles called transformers now convert this to the 120 volts coming out of our walls in our homes, which we plug our appliances into our electrical outlets. So this movement of these electrons bumping into each other creates great friction, and friction causes heat. So heat can lead to fire. So if we have devices that get overheated and wires that get overheated, this can result in a fire in our home. Very, very dangerous. Okay. Our home can also be endangered when these devices cause an electrical shock. Right? We touch a device that shocks us. A wire coming out of an extension cord, for example, if the insulation around the cord is damaged, so the insulation is the part that doesn't conduct electricity, the rubber or the plastic that surrounds an extension cord, for example, it might be damaged. And if you can see the wire, that damage can cause fire because that insulation is no longer there to protect it. If that cord runs underneath a rug, right? Oftentimes people run the cord underneath a rug. It's connected to an electric heater in the wintertime. That damaged part of the cord can ignite the rug and cause a fire. We could get shocked if an electric current is flowing through an appliance or an electrical tool like it's not supposed to, basically that means the wiring inside is damaged. And so now the surface of the device has a potential electrical injury associated with it if we touch it. So there's voltage on the surface of the device. We can touch it and our hands are shocked. All right? We could be seriously injured. We could be burned. We could be seriously injured. So these are some of the dangers associated with electricity. You can check your home's wiring. For one thing, the wiring must meet national, state, and local regulations. So it is suggested that a qualified electrician installs the wiring in everyone's home. So this may be a job that some of you young people watching this lecture may be interested in performing later in your lives. Okay. Here you can see we're discussing that the wiring must provide ample power. Okay. According to our booklet, the metal box for the circuit breaker or the fuses should be rated for at least 100 amps. If it isn't clearly labeled, or if your home's power is delivered through ungrounded outlets designed for two-prong plugs, have the wiring inspected and upgraded. So basically, if you have an older home, you'll see fuses in the basement in a fuse box. So the fuse is made out of material that it dissolves easily under current, and they're rated for different values of current. Current is rated in terms of amperage. So the fuse will dissolve if too much amperage flows through it and it stops further current from flowing. So most electrical devices have fuses in them. Even your car has a fuse box, your parents' car. So you could ask your parents to show you where the fuse box is, and you'll see fuses located in there. So they will open up. They basically burn out and open up if too much current flows through. So if too much current flows through and it doesn't open up, then you can get a serious problem like a shock or a fire on the other end of where the current is headed. So that's the purpose of the fuse. Newer homes have these breaker boxes in them where they basically have these switches that when too much current flows through them, the switch opens up. The switch opens up, and so now no more current can flow. Thus, no more damage can occur. So this damage is occurring when you use the wrong wires in your home. If the wires are too thin, they can't hold enough current for the devices you plan to run. So you must be careful that the outlet that you install a device into, like your refrigerator, okay, or your electric stove, which is going to use a lot of current, it's got to get plugged into a wall outlet where the current that's going to be drawn by the device, like the electric stove, matches up with the amount of current capable of being delivered through the wires coming through that electrical outlet. Okay, so this section of the text discusses how the metal box for circuit breakers should be at least 100 amps, as I mentioned before. You need 3 kinds of circuits in your home. Fixed equipment circuits for high wattage appliances like stoves and dryers. They use a lot of electric power. You need 20 amp circuits for laundry and kitchen circuits, and portable appliances like toasters or irons. Okay, their maximum use would be up to 20 amps. And general purpose circuits would go down to 15 amps, like for a radio or a TV. And you must also be careful if your home was made between 1965 and 1973. It could be using aluminum wiring, okay, which needs special examination. Okay, aluminum wiring cannot hold as much electrical current. You know, it's more hazardous to being melted and destroyed. Okay, so you can see in this section we're talking about circuit interrupters that'll shut off power, which is, as I had described, we have circuit breakers in our basement that basically just switches that open up when too much current flows. So some places where too much current can flow also would be your bathroom. You know, wherever there's water, water is a great conductor of electricity. So if water gets around anything electrical, that's a potential hazard. Do not use anything electrical in the bathtub or the shower. Always be ready for wiring problems, which you can tell by if the lights in your home dim, if they start to flicker. If you got a motor that changes speed, you're using your electric can opener and all of a sudden the speed of it changes, that could be a sign of a wiring problem. If your circuit breaker trips, then you lose power to some part of your home, you know, and so the electrical devices don't work any longer, and that circuit breaker opened up in your basement. See, that indicates there's a problem somewhere between that circuit breaker and your appliance, you know, so that would have to be investigated. Is the problem your appliance shorting out current? Is the problem in the wiring? The wiring somewhere is no longer being insulated. So circuit breaker going off is a sign that some hazard exists that must be cared for. If your electrical devices aren't doing exactly what they're supposed to do, like your toaster isn't getting your toast toasty enough, your iron isn't hot enough, the picture on your television screen isn't big, if it's not, you know, if it looks funny, if it's not taking up the whole screen, that's a sign that this could be an electrical problem associated here. Okay, so looking at this page goes into more detail about what I previously discussed. We have fuses and circuit breakers, which they shut off electric current to protect you from an injury or protect the home from a fire, in case there would be some sort of a short circuit wherever bare electrical wire is exposed, or if there's overloading. If you put too many appliances into the same electrical outlet, you can overload that outlet and too much current flows through the wires and the wiring can be damaged. So you cannot, you know, if you put like an extension cord whereupon you plug in multiple devices going through that cord, that can cause a wiring problem. So overloading is a big problem. Or any kind of damage, electrical damage internally in an electrical device, you know, where a wire can be exposed, that can just cause, so that's basically an electrical device which can cause the problems that I've described. It can cause the possible, you know, shock when you touch it, you know, possible burning, you know, burning in your home or so forth. So if a fuse ever blows, unplug the appliance that caused that fuse to blow, replace the fuse. Okay? If the circuit breaker gets tripped, unplug the appliance that caused that. You got to find out what's wrong with that appliance. You could take that to the, you know, a repair person, a repair organization, or, you know, if you're, you know, if people in your home are very adept at electronics, perhaps they could repair that appliance for you. Then you got to go down and close that circuit breaker again so that anything else that you plug into that circuit will be able to work properly. So First Energy thinks you should call an electrician if, you know, if you can't find the problem, so call in some professional help. Never replace a fuse with something that will just conduct electricity. Some people do that, like they might put aluminum foil in there, or they'll put a penny in there. Okay, now that's not a good idea, because the whole purpose of the fuse is to blow, open up. Okay, it's called blowing a fuse. It opens up and dissolves, opens the circuit. So when that happens, no more current flows through. So if you put something in there that's forcing current through, that is a big mistake. Never do that. You should always keep a flashlight handy in your home, okay? Because if you have a big electrical problem, sometimes even the power company has a problem where their electrical lines have been touched by, a tree or so forth, which basically shorts the current out to the earth ground, okay? And so you don't have current flowing in your home. So if you have some emergency flashlights around, that's very helpful. Okay, so you must also maintain your cords on all your electrical devices. Use the appropriate extension cord. So you must look at the amperage rating. So amperage is the amount of current flowing through the cord. You must make sure that that is matching the amperage rating on the device you're plugging the cord into. So you can't have a real thin cord and a real heavy high voltage device, high current drawing device that's going to draw lots of current and possibly destroy that extension cord. That won't work. That's a mistake. If you're going to go outdoors with your device, like you're using an electrical lawnmower or an electric drill outdoors, make sure you have a weather resistant cord. Make sure that those, your power tools have those heavy duty cords, because they take a lot of energy. They take a lot of electrical energy. So if you have a 3-wire cord, make sure you use a 3-prong plug. So that third prong is for grounding, which is for safety purposes. Okay, so it's suggested that you not use an adapter. Okay, you put an adapter onto a 3-prong outlet, right, and that becomes a 2-prong outlet. That's really not a good idea. You're getting rid of that third prong, which is for purposes of grounding, which basically takes the current to ground for protection purposes. So it's best not to put those adapters on your 3-prong cords. Whenever you plug anything in, or you're working with electrical appliances, or you're playing with them, never twist the cords or crush the cords. Don't pull on the cord. When you disconnect it, pull on the plug. When you pull on the cord, you can break that cord internally, so then the wire will be broken inside, which can lead to the problems we described. Now you've got a thin piece of wire in there, and that can burn if too much current flows through it. So pull at the plug, not at the cord. Don't twist up the cord whenever you plug a device in. Don't put a cord where people walk. People can step on the cord when it's a walkway in your home. It can get easily damaged. Keep the cords away from anything that's hot, like your heater or your stove. Make sure cords don't go near anything that gets hot. And make sure cords stay away from water, because the water conducts electricity very well. So if there is any small amount of damage, that water is going to conduct that electricity very well. Keep it away from watery areas. Be careful using electrical things near your kitchen sink or your bathroom sink or bathtub or so forth. Always inspect your cords for signs of wear. Make sure there's no damage on your cords, and never wrap your cords around pipes or appliances. If you do find them broken, replace them quickly, because a worn cord can cause shorts and shocks and sometimes a fire. Here's some safety tips for your appliances. Make sure your appliances have those laboratory testing labels on them. That shows that they've been thoroughly examined by people familiar with what they're supposed to be able to withstand. Things like water heaters and furnaces as well. Make sure that they have those safety testing labels on them. Always, make sure you save all your owner's manuals on all your devices. In case there ever is a problem, you can possibly look up your owner's, problems in your owner's manual to help direct you on what to do. And if you do get stuck, you could call it an electrician, which may be something one of you young people would like to become later in your life. possibly an electrician or possibly an electrical engineer. Now, if you have a heat-producing appliance, like a heater or a toaster or a stove, you got to be extra careful because that heat can produce fire. Don't put any kind of paper near heaters. Don't put your drapes near your heater, or don't put heaters near your furniture. Keep them nice and clean because dirt can help a short circuit, make more current flow. Okay, so keep them nice and clean. Keep them away from people so that you don't accidentally touch them, or any young children in your home may accidentally touch anything that gets hot like this. When you're not using them, unplug them. Put them in a nice, safe place after they get cool. You certainly don't want to unplug a toaster and then put it back into its box, or your heater and put it back into its box, because now that it's hot, it could get that box on fire. Okay, so never operate an electric appliance while touching a metal object, especially in your basement when there's plumbing, or standing on a wet surface. So if you're operating an electrical appliance, like your hair dryer, make sure that you're not standing in any kind of water, because that's making a good electrical connection. So if there's a problem with the appliance, like bare wire touching the appliance case somewhere, that electricity can flow from the appliance through your body, through the wire that you're standing in. So make sure that you're not on any kind of a wet surface. Make sure never use anything like this in your bathtub or your shower. Don't use your hair dryer in your shower. Unplug your appliance before you clean them. Okay, so like an iron or a hair dryer, unplug them when you're not using them, and definitely unplug them when you're cleaning them, because if you're going to clean them, right, if some damage occurs, then that electrical short now goes through your body. So you want that appliance unplugged whenever you do anything to it. Always clean any kind of thing with an electrical motor on it in your home. So electrical knives and electrical can openers, common things with that are powered by electrical motors in a home. Never insert a metal object into an outlet. Okay, sometimes young people might want to play by sticking things in the metal outlets, which is very dangerous. Possibly you could be killed by such a thing. Never just stick anything into those electrical power outlets, and make sure all the young people know this. Don't let them play with electrical cords or the wall outlets. In fact, there are plenty of different types of safety caps you can put to cover those things so that young people don't get near them. It's best not to use extension cords. Okay? It's best to use that cord that's been made part of the electronic appliance that you're going to operate in your home. If you try to extend its use with an extension cord, that cord could be of a different size. Okay, it could be too thin, and then that would cause a short circuit as the overcurrent flows through that wire. So it's actually best to try to not use an extension cord if you don't have to. If you ever see smoking or sparking, or you do get a shock, okay, get your service person there to inspect any kind of device. Don't use it again until it's been inspected and passed as safe. Now, power tools are a very common item. Electrical drills, electrical sanders, so forth. Maintain those tools by keeping them clean and in good condition. Store them in a dry place. Right? You want to keep these things dry. You don't want these things to get dirty. The dirt can conduct electricity, leading to shorts. Water can conduct the electricity, so if these things get wet or dirty, that's a danger. Keep them dry and clean. Inspect them regularly. If you see any problem, immediately be sure not to use it. Call somebody that is familiar with correcting such problems on these devices. Make sure that your cords never get too hot or never get near any kind of chemicals. Okay, so I'm going to ask you a question. As I said earlier, I told you where you can answer this question. Tell me what a fuse is and why a fuse is used. Okay? Have a very nice day and stay very safe with your electrical appliances. His tool powered by electricity in the ground where there was an electrical line running. So here's some experiments with conductors and insulators. Get a 1.2 volt light bulb, get a D-cell battery, 3 pieces of copper wire, and a banana. Set the equipment up the way this picture shows. So they're basically making a circuit here. They've got the banana in the circuit and they've got a light bulb in the circuit as well, and the battery's powering the circuit. So get a friend, get a bunch of objects like lemons, paper clips, see if they will power the circuit. List the items below that will electricity flow through the circuit. So they're basically testing to see if the banana will conduct enough electricity to let the light bulb light. And then they want you to see if you put a lemon in there, will that conduct enough electricity to let the light bulb light? And if you put a paper clip in there, will that conduct enough electricity to let the light bulb light? Put your objects in there one at a time, see what happens. Now take one of your objects that was an insulator and soak it with water and then put it back in. So if if the light bulb didn't come on when your banana was in there, put your banana in water and put it back, and now see if the light bulb comes on. So that is an experiment you could do to conduct on electrical conduction at home. Here we have some electric art. Okay, so what I'd like you to do, the question I want you to answer, I'd like you to tell me what happened. How was this man that was injured badly with an electrical wiring line, what was he doing that injured him, and how was he brought to a form of recovery?